Hello and welcome to lesson 2.4, chain rule. Today we're going to find out how to find the derivative of a function that's a composite function. So in this case, g of x is inside f of x. So to calculate the derivative of such a function, using power notation or prime notation, so to calculate y prime, you're calculating f prime of g of x, and then you're multiplying by g prime of x. Or if you're using Leibniz notation, to find dy over dx, which also is df over dx, you're finding df over dg times dg over dx. And it looks like the dg's cancel each other out here. So, let's see how Leibniz notation works a little bit more closely. So if you have a function with inside another function, you state the inside function as something equal to 4x minus 7. So we're going to use the u in this case. And then that means y equals u cubed. So to calculate dy over dx, you're taking dy of du, and you're multiplying du of dx. Well, y in this case is u cubed, and u in this case is 4x minus 7. So the derivative of u cubed is 3u squared, and we multiply by derivative of 4x minus 7, which is just 4. So this simplifies to 2u squared, and if we want it in terms of x's, because that's what this expression is looking for, dy over dx, and with respect to the variable x, you've got to replace the u back in as 4x minus 7. And there's how you work out the derivative with respect to u. And there's how you work out the derivative with respect to x, using Leibniz notation. So let's see how we can do this again. Let's try this time with prime notation. So to calculate the derivative of this, I'm going to first rewrite this as 2 times 3x minus 4 to the exponent negative 3. Now remember, 2 is a constant, so it's not going to change the derivative. So I'm going to take that negative 3, bring it down, and I'm finding my derivative. So 2 times negative 3 of 3x minus 4 to the exponent negative 4. You'll notice here the 3x minus 4 did not change. It's still the same expression that you had before. But now we multiply by the derivative of 3x minus 4, which is the value of 3. So remember, this is the derivative of the 3x minus 4, the inside function. And then we simplify from here. So 2 times negative 3 times negative 3 is negative 18 of 3x minus 4 to the exponent negative 4. And again, most likely you're going to rewrite this derivative so that you have your positive exponents. So this turns out to be negative 18 over 3x minus 4 to the exponent positive 4. Okay, let's try something else. Let's find the derivative of this function. Again, rewrite this as f of x equals 3x squared minus 4 to the exponent of a half. Derivative, we bring the half down, we multiply, keep the inside the same, so this is 3x squared minus 4. Now to the exponent negative a half. And now we multiply it by the derivative of what's 3x squared minus 4, which is 6x. We simplify. A half of 6x is 3x. Times that by the 3x squared minus 4 to the exponent negative a half. We move the negative half to the denominator, and because it's a half, we change it back to a square root. So this is 3x over the square root of 3x squared minus 4 is our derivative. Okay, let's try something with product chain rule. So product chain rule, remember that we're finding the derivative of this first, leave this one alone, and then leave the first function alone and find the derivative of the second one. So the derivative of 2x minus 3 cubed is 3 times 2x minus cubed to the exponent's 2. Find the derivative of the inside, which is 2, and now leave the 3x minus 1 squared alone. We add. This time we leave the 2x minus 3 cubed alone. I bring the 2 down. I multiply by 3x minus 1. The exponent now becomes a 1, and the derivative of 3x minus 1 is 3. Now we simplify. So this becomes 6 times 2x minus 3 squared and 3x minus 1 squared plus 6 times 2x minus 3 cubed times 3x minus 1. Now again, most times they want to have this in factored form, so you want to factor this. Common factors between all of this is 6 2x minus 3 squared and 3x minus 1, leaving 3x minus 1 plus 2x minus 3. So this final derivative simplifies to 6 times 2x minus 3 squared times 3x minus 1 times 5x minus 4. And there we go. Okay. Now we can also find derivatives of quotients using the same kind of idea. So first, take the numerator, list the denominator beside it, in brackets to the exponent negative 1. Apply the derivative. So the derivative of 3x minus 1 is 3. Leave the 2x plus 5 to the negative 1 alone. Add. Now leave the 3x minus 1 alone. Find the derivative of the 2x plus 5 to the exponent negative 1. Like so. Find a common denominator. Well, most common item right here has the lowest exponent. So the lowest exponent right here is actually a 2x plus 5 to the exponent negative 2. That's the one that's common. So we're going to common factor that out. That leaves me with a 3 times a 2x plus 5 here for my first term. And from my last term, leaves me a negative 2 because of the negative 1 times the 2 times the 3x minus 1. Okay, so now we continue to simplify. This becomes 6x plus 15 minus 6x plus 2. So now the derivative turns out to be just 17 in the numerator and 2x plus 5 squared in the denominator. And that's how you find out the derivative of a function that's a rational function. And thus concludes lesson 2.4.